Does multiple regression, what does multiple regression have to do with correlation and causation? Apply your answers to fewer than 200 errors.
Multiple regression attempts to identify a set of explanatory independent variables that can be used to model the expected behavior of a dependent variable. In order to work properly, the model must be specified properly. Correlation between the predictions of the model and the actual behavior of the dependent variable is a measure of the effectiveness of the regression.
Okay.
How do you think the regression results, coefficient-wise, are your correlations? Whereas causation is more complex. That's an assumption of the model. By putting the variables on the right-hand side of the equation, you're assuming there's a causation between them and the
Right. Mm-hmm. Did everybody hear that? Understand that? What he's saying is that we take, will become a little bit clearer when we get to the next one. You have a data set. Let's say you run a simple regression, home runs and salary. You decide you flip a coin, you want to put salary as your dependent variable, and home runs as your independent variable. And then you decide to do it the other way around. The results are not going to be exactly the same for all of the data set, but as far as the correlation between the two, it will be exactly the same. So the correlation is more of a mathematical term. What's your name again? Lacey. Lacey's saying is that the assumption when you were building the model, when I sat around and I flipped the coin instead of sitting around thinking it through which one is actually affecting the other one, that is what causation is introduced in the model. That's in the hands of the model builder, and the correlation in effect is kind of the result of whatever the program spits out. In other words, program can't tell the difference between which one's affecting the other. Cannot determine which one's causing the other. At least for a very simple regression, you can't tell the difference for the ones that you get for this one.
So you're saying that multiple regression proves that the causation relationship between the dependent variable and independent variable?
I'm sorry, can you repeat that?
You're saying that the multiple regression proves that the causation between the dependent variable and independent variable?
No, what I'm saying is that, well, I was just explaining what he was saying. I hope I explained it properly, which is that at least for a simple regression, if we just take it on the simple side, we have two variables, one's independent, one's dependent. We want to run a regression. We're going to come up with certain statistics. We're going to have a coefficient. We're going to have certain information that we're deriving from it. And then if we flip the two, let's say, we're going to have the same information being spit out. So what that's telling us is the correlation between the two. What we have to do is, as model builders, is to figure out which one is causing the other. So the statistical program is not going to do that for us. So we have to end up producing a model that will end up telling us which one is causing the other one. Be able to put the one that's causing the other one as the independent variable and the one that's being affected as the dependent variable. Does that make sense?
In the technical sense, I understand that the multiple regression explanation says that just there is a relationship, so the linear relationship between dependent variable and independent variables.
Right.
In the case of multiple regression, while the other constant variables are constant. So I'm understanding that there's no causal relation. You cannot say that there's causal relation between dependent variables and regression.
You're saying that you can't come up with, well, if you come up with a
But
regression.
intrinsically, while we are modeling, we can say that one causes independent
Right.
variables cause dependent variable.
Right.
But statistically, in the numerator setting, you cannot say that there's a causal relationship between.
Right. That's exactly what I'm saying.
So
Yeah.
to prove the causation in the econometric setting, we, by understanding that we have to use the, simultaneous efficient modeling, two-stage model.
Well, I wouldn't worry about any of that just yet. Those are, things that, you know, you might not even get a 2 in this course. You might have to take that in Econometrics 2. Where you get some of these things. Some of those things are, yeah. This is pretty much, trying to get you, I mean, I don't know, I haven't taken it in a while, so I can't tell you for certain. I can take a look at the full syllabus. You like to talk to me after class with the full syllabus and see if it's covered. But it's a few steps from where we are now. Right now, we just want to feel comfortable with correlation, causation, the basics around, excuse me, setting up a model properly. But basically, what you said there is exactly what I'm saying. And it's up to the mathematician to determine causation and form model properly, and it's up to the computer to determine the correlations.
If am I right, the vertical relation just shows that the linear relations between the dependent and dependent, not the correlation. Am I right?
Right.
Does it make sense to run regressions on variables that are not causal, then how do you think it independent using the variables?
You have to just think it through for the most part.
But
There are some ways that you really, you know, it's first class in Econometrics 1. I don't even know if he's going to get into it in this class. But there's certain ways that you can get around to try and figure it out mathematically.
Is R squared is R squared factored into regression and correlation and causation?
No, not really. I'll get to R squared and probably very quickly. I'll show you my regression results and I'll explain it very briefly.